Okay, so how did you get on with question 6? This is the one with the two identities that we've got to prove. Let me show you how I answered it. Okay, so we've got the two identities here to try to prove. I'm going to start with a right-angled triangle. And you can see this is better than my hand-drawn ones. This is one I prepared earlier. And what I'm going to do is label the sides. It's a right-angled triangle. I'm going to label the sides, I don't know, A, B, and C. No particular special order. And label one of the other angles X. And then using what we already know from GCSE, we can write down sine X, cos X, and tan X. So sine X, opposite over hypotenuse, that's A over B. Cos X, C over B. And tan X, opposite over adjacent, A over C. So before I move on and use those three trig ratios, is there anything else I can write down about this triangle? I hope you're saying Pythagoras. So let's write down Pythagoras for this triangle. A squared plus B squared equals C squared. No, that's not right, is it? Start again. A squared plus C squared equals B squared. So these things that we've written down are true for any right-angled triangle in the universe. Okay, so let's now set about trying to prove the first of these identities. So we're trying to find out what sine X divided by cos X is. Sine X is A over B, and we're dividing that by cos X, which is C over B, and that's the same as A over B times B over C. The B's cancel, leaving us with A over C. And when you look up here, you see that A over C is the same as tan X. So what we're saying then is that for any angle X, sine X divided by cos X is exactly the same as tan X. You can try that on your calculator. If you type sine 24 divided by cos 24 and then find out what tan 24 is, you'll find that the answers are exactly the same, whether you're in degrees or radians. If you know about radians yet, it doesn't matter. So that's the first identity proved. Let's look at the second one. Sine squared x plus cos squared x is identically equal to 1. So sine squared x, basically what is that? That is sine squared x is sine x all squared. So that's A over B all squared plus cos x squared, which is C over B all squared. So when we get rid of the brackets, we get A squared over B squared plus C squared over B squared. And when we combine those two into a single fraction, we have got a common denominator, which is B squared and then the numerator is a squared plus c squared. Hang on a minute. Let's look up there. A squared plus c squared is the same as b squared. So therefore, we've got b squared divided by b squared. Now that is the same as 1. So therefore, sine squared x plus cos squared x is always the same as 1. So I thought I'd just add a little bit of a discussion here about identities and what makes an identity and why is that different from an equation. Well, the key thing is that an identity is true for all values. So for example, taking the sine squared x plus cos squared x is identically the same as 1. It doesn't matter what value of x we choose. So for example, if we had sine squared of an egg plus cos squared of an egg, that would still be equal to 1. If we could take the sine and the cos of an egg, I'm not sure we can. Sine squared of 3x plus cos squared of 3x will be the same as 1. Whatever we put into those two brackets, it's going to be the same as 1. So we can put 2x minus 50 in both the brackets. That's absolutely fine, and it will still be equal to 1. We can also turn this identity round, so we can say that sine squared x is the same as 1 minus cos squared x. And we can make a similar identity for cos squared x by rearranging that first identity. However, if the things in the brackets are not the same, in this case we've got x plus 20 in the first bracket and x plus 21 in the second bracket, it's no longer equal to 1. It's not identically the same as 1. Looking at the other identity, the sine over cos equals tan. So sine of 2x over cos 2x is identically the same as 2x, tan 2x. And again, if we put anything we like inside the brackets, h minus 10 in this example, sine of h minus 10 over cos h minus 10 would be the same as tan h minus 10. But the sine of 92 over the sine of 91, now these two things are different. So that will not be the same as the tan of 92 or 91 or 92 over 91. Okay,